CloudDB, shaping your new normal.
Welcome everyone to the 2021 APAC Groundbreakers Virtual Tour by Apaco UC. This year our event will be the biggest one ever done with 144 sessions, including normal sessions, workshops, and hands-on labs from 100 different speakers over 18 days. Also, it will cover sessions in 4 different languages. Please remember to register to as many sessions as you can. This way I will have access to the replays until the 30th of December through the platform. I would like to say thanks to all Oracle user groups and Java user groups that made this event possible, and also to our sponsors, Oracle Groundbreakers, and your main sponsor, CloudDB. Now for today's session, getting started with Python and Oracle Autonomous Database by Christopher Jones and Sharad Chandran. Please feel free to use the chat window in your right lower corner to make any questions. If English is not your first language, you also have at the side of the chat option translation that you can basically write in your own language, and we will see that on English. And you can make questions at any time to the speakers through the chat, and they will be answering at their convenience. Also, if you have any issue with the platform, please use the same chat window to let me know, and I will try to help you the best I can. Now, without any more further ado, I would like to leave you with this amazing session by Christopher Jones and Sharad Chandran. All right, the room is all yours.
Thank you, Francisco. This is a huge conference. You've done a great job here with your team. Thank you very much for that. My name is Christopher Jones. As mentioned, I'm here with my colleague Sharad Chandran, and we're going to present on getting started with Python and Oracle Autonomous Database. Quite a lot of content to get through, so I'm just going to run through a few quick slides just while we're waiting for the last few minutes of people to join. This is what our group looks after. We look after all of the database access APIs into Oracle Database. And Sharad and I focus on the C stack, the C languages, and obviously today we're speaking about the Python CX Oracle API. Last sort of slide before we get into the demos. This is what CX Oracle is for people who are really brand new. It's a thick client driver. It conforms to the standard Python DB API specification. There are 1 or 2 things which Oracle Database doesn't support. There's a whole bunch of extra things for queuing and continuous query notification, etc. But it's easily installed. It's available on the PyPy repository. There are RPMs available. Sharad will show some of that later. It is a thick client install, so you need to have Oracle client libraries. These talk across Oracle Network to the database, and database today is obviously going to be in Oracle Autonomous Database. And
Hola a todos, ¿cómo están?
Francisco, can you mute yourself?
Bien, gracias a Dios. Espero que estén todos bien por ahí.
Francisco, Sharad, maybe you can just bring him to mute
Bien,
yourself.
aquí con el otro laptop aquí al lado con la conferencia corriendo ahí y ahí es multitasking.
Okay, let me continue. So it doesn't require a thick client stack.
¿Cómo han andado las conferencias?
Background noise.
Bien, los attendees son flojos, quieren todo, la mayoría ver con los replays después, entonces ahí estoy bajando.
Oh, look, I can mute him. Okay, great. As a presenter, I get that power. Okay, problem solved. Okay. Apologies for that, everyone. Where were we? So yeah, thick client stack. So you need the Oracle client libraries installed. They're easily available. RPMs, as we show, they're kind of automatically installed. Zip downloads, there's no click-through anymore, so it's a straight wget and unzip if you're on a non-Linux platform. Long history, very stable, widely used, many downloads a month. I think we're up to like 3.5 million downloads a month of the CX Oracle driver. So it's very popular, used in frameworks, Django, SQL Alchemy, Pandas, and we're actually going to just show a Flask application today, which is a kind of agnostic framework. So we are going to show, Sharad's going to show how to set up Autonomous Database, set up some compute infrastructure, do the installations. He's actually going to do that as a video pre-recorded. Obviously, you can cut out a little bit of what time there. And then he's going to go into a live demo, and I'm going to walk through the Flask app with you, how we just configured that and set that up. Live demo of it running, so there's a mixture of slides, video, and demos. And at the end, I'm going to talk a little bit about the continuous availability, the high availability. So Sharad, with that, I'm going to do slide work and you're going to do the talking. What are we going to show today?
Thank you, Chris. Thank you for that nice lead-in. Are you able to hear me?
Yes, go ahead.
Okay. Okay. So in this demo, we will create a web service which is created in the if you can just run through the animation. In this demo, we'll create a web service which is running on Linux Cloud VM, and this web service on the Linux Cloud VM will talk to the Oracle Autonomous Database and process data. As you can see, the flow is that the user will create a web request to the web service, and the web service will fetch data or fetch data, or it will upload data based on the web request from the customer, and then it will return a result back to the customer in their web browser. So the customer or the user will use the web service to fetch or upload the required data. So moving on to the next slide. So I just wanted to touch a bit on the components that we'll be using for this demo. So in addition to the CX Oracle Python module that Chris has already mentioned, we'll also be using the Flask framework. Flask is basically, as most of you may have already known, is a lightweight web framework of Python. It does not enforce any dependencies. So when I say it does not enforce dependencies, it means that there are very few tools and libraries that needs to be installed for Flask to be up and running. The core is very simple for Flask, but it can be extensible, which means that you have a lesser amount of base code when compared to other web frameworks that may be available in the market, like Django. And Flask is used to build a very simple web service usually, and it can it will build this working application from ground up in a very short amount of time. There are two core dependencies that Flask generally uses. It's called Jinja2 and Workzeug, which basically offer the web server gateway interface feature and the templates feature for the Flask framework. So moving on to the next slide. We also a quick note on the Oracle Autonomous Databases. So the Oracle ADBs will be is available on Oracle Cloud Infrastructure. It is a fully managed and pre-configured database service with 4 types of workload available. You have the data warehouse, which is used to deliver fast query performance without any database admin intervention. You have the autonomous JSON database, which is used for developing NoSQL style applications, primarily for JSON documents. You have the ATP service, which is used for transaction processing in real time and for mixed workload applications. And finally, you have the Apex application development cloud service, which is used for rapidly building and deploying low-code applications. So we will be connecting to an autonomous data warehouse service. Next slide, please.
Yeah, let's start the demo. I'm going to stop sharing, and in fact, we can turn off our videos, I guess, just to give more screen real estate.
Sure.
So let me stop, and you can start, since you'll be running the video first.
Sure. So I will run the video quickly.
Okay, just waiting for it to come up. There we go.
Okay. So let's quickly get into the demo of setting up the Oracle Cloud Infrastructure. So in Oracle Cloud Infrastructure, we are going to set up the database and the Oracle VM for running the app web service. So quickly setting it up on cloud. You can quickly do a Google search for Oracle Cloud and then sign into the Oracle Cloud Infrastructure. I've already created an account. It's quite easy to create an account, and remember to always create the always free account. And as you can see in the Oracle Cloud, you can create you can generate your own resources or create your own resources like a VM instance or a database. So in this case, pretty much we require an ADW database, which is the data warehouse. So let's now provide some basic information. Let's give it a more user-friendly name. I'm going to call it Oracle Test DB Python demo. Leave the database name as it is. As you can see, we are going to create a data warehouse and leave it as shared infrastructure. Now, one important thing, at least as far as this demo is concerned, is to always select the always free configuration. Set your own user ID password. And leave the rest as it is. And you can create your own database. So your database will be provisioned in another 2 minutes. So now that your database has been provisioned, you would need to download the wallet so that you can connect to the database from pretty much any machine. To download the wallet, you have to click on the DB connection button that you see in this console page for your newly created database, and then you can download the wallet. You can give your own password for the wallet. I'm giving my own password. The user ID will be the admin user that you have created for this wallet. So let me save it in my local machine. Now let me quickly go to the location. As you can see, you have a lot of files over here. The main file that you would need for this particular demo is the SSO file, and obviously the SQLnet and tnsnames.ora file. So let's quickly take a look at tnsnames.ora file. Open it in my notepad. Okay, let me extract it first. Okay, so one thing I wanted to point out over here is that you have the DSN name. So it is always important to remember the DSN names, and this wallet would need to be copied to the app service machine as well as your local machine, and so that your app is able to connect to the database. Okay, next up I want to create a VM instance where we can deploy the app and the web service. So to create a VM instance is quite simple. We go to create a VM instance section, and then as you can see, you can give any name. I'm just going to call it Cloud Linux VM, since we are creating an Oracle Linux 7.9 VM. You can download this private key as well, so that you can use it later to connect to this VM through Putty instead of using a username and password. So let me quickly save it. Create the VM now. Yep, now the VM is getting provisioned. Let's wait for a few minutes. Okay, my VM is up and running. The main thing to note here is the public IP address of your VM and also the private IP address. So quickly I'll note it down here. Because we would be later using the public IP address and to connect using the Putty terminal. Now we need to connect to the Linux VM instance, where you will create and run the app, which will in turn create the web service, which you can use to access the data from any machine that you may have. I'll be using my local machine for this in this case. So in one quick note, in addition to the public IP address, you also need to take your username and your private IP address and store it in a safe place, possibly a text file, like I've done over here. Okay, let's so to connect to this Linux VM instance, you can do it using a Putty terminal and an SSH connection, or you can connect using a VNC server. I'm going to use Putty terminal and an SSH connection. So to get this SSH connection, you have to use the private key file that we downloaded when we created the instance, and using this you can connect without having a password. You can connect just using the username and this private key that you create. So for Putty, you have to create a separate Putty specific key. For that, you go to PuttyGen and you take the key that you had downloaded earlier. I had stored it in my downloads folder. This is the key that I downloaded when I had created this Cloud Linux VM instance. Once you have put it in the key generator, you have to save this private key. Just click yes. As you can see, you can save it using any name you want. It will be stored as a .ppk file, which will be the key file which can be read by the Putty terminal. So I'm saving it over here. All done. Let me quickly navigate back to the downloads folder. It is done. Now let's connect to the Linux VM terminal using Putty. So open the Putty app. So the host name which I have stored here, I'll just copy paste it. You have to use the public IP address over here, and you have to use it in the user. You have to give the username also. So you have to say username at the public IP address. Also, you need to set the SSH key. You have to go to path and you have to point to the SSH key that you had just now created for Putty. And one more thing is that you may need to set the proxy if you're working behind a company firewall or a proxy. So I have set the SSH keys, I have set the proxy. Now let's run it and open our terminal. Okay, as you can see, we are connected now. Let's check the directory that we are in. So now we are able to access the VM instance that we have created. The one advantage that you have with the Oracle Linux VM is that it comes with Python installed. So if you just type Python 3 version, so your Python is installed in it. We also need to install a couple of more tools and utilities to get our app up and running. And the very first utility that you need to install is the CX Oracle module of Python, which we had discussed earlier in the slides. I'm now trying to install CX Oracle, and it's as you can see, it is installed quite quickly. Okay, now I have increased the font size here just so that you can see it clearly. Now we need to install the instant client libraries so that you can connect to the Oracle Cloud ADB Autonomous Database. So for that, we have these two commands. By the way, all these commands are available in our Oracle website. So you can look for quick start, Python quick start for Oracle databases, and you will be able to see how to libraries in your VM or in your machine. You have to select Y here. Okay, now we need to install this was the prerequisite package that needed to be installed. Now you need to install the actual instant client libraries. Select Y here as well. Okay, your instant client installation is complete. So usually if your instant client libraries are installed correctly, they will install in the /user/lib folder. It is installed under a folder named Oracle, and with the version, it will have the version name, and it will have the client folder, and under that you have the bin and the lib folder. So we'll be using the basically the lib clntsh.so file when we connect to the database from our app. So just a quick check for you. One more thing that you may need to keep in mind is the network directory. So if you go to cd network /admin, so here you may want to copy all the database wallet files when we copy it later. So just something to keep in mind. Now the next step is to run the ld config utility. So you would whenever your Python app runs, it will look at the folder pointed by the ld config utility to find out where the instant client libraries are. So to check that, what you would need to do is you would need to run these two commands. So what this does is the path to the instant client libraries is stored in this particular folder, which will be utilized by the ld config utility. So this will load the library, the instant client library path, and when the app runs and tries to access the database, it will look for the instant client in the libraries set within this file. So I'll quickly show you this file also. As you can see here, it just contains the path information of the instant client libraries. Okay, now that the instant client libraries are configured, the last step here is to copy the wallet files that we had downloaded for the ADB. Now to copy the wallet files from my local machine to this Linux VM, we can use the various file transfer tools that are available in the market. I am using WinSCP. Since it is quite easy to set up, and the configuration is similar to how I did for the Putty terminal. So as you can see here, I'll give the public IP address, the username is OPC, and of course you can set the key. And the proxy as well in case required. Okay, I set everything and it is running. Yep, now I'm able to access the VM on the WinSCP client. So I would like to transfer the wallet, which is available in my downloads folder. I'll copy the zip file since it's easier. Just drag and drop it here, and it is copied. To check that it is copied, let's go back to the terminal, give ls. As you can see, the zip file is copied. Now we need to extract this zip file and copy it to the network admin folder for the instant client libraries that I told you earlier. So to run it, I'm going to use the cp command, copy command. And then now the zip file is copied, I need to unzip it. So the wallet, all the wallet files have been copied to the network admin folder of the instant client libraries. To check it, let me quickly go to that folder. As you can see, everything is copied over here. And when I look at tns names.ora, you have the database details. Okay, one more thing I forgot. We need to install the Flask Python module as well. So quickly running it here. One quick tip that I wanted to give you is that in case you cannot add your wallet files to the user lib folder, then you can always copy it to another arbitrary folder. And one more, you have to do one more setting. You have to set the TNS admin environment variable to the wallet directory, and so the wallet directory will contain all the wallet files as well as the SQLnet.ora and tnsnames.ora files. So if you do not have access to the user lib Oracle folder, then please you set the TNS admin environment variable for the app to work. So now we are ready to run the app. Okay, can you hear me? That was a
yes.
Yep. So that was okay. That was a pre-recording to show you how to install and configure the cloud infrastructure for running this for running the app to connect to the autonomous database. Now Chris will give you a brief insight on how the app demo app is structured, and then we will look at running the app. Chris, over to you.
Thank you. I believe I've correctly shared. I didn't stop you, so you might just want to confirm that.
Yep.
So two things actually just about the video. One is you showed downloading a wallet, and obviously wallets are important. Some of you may know that in the JDBC world, we recently enabled what we call one-way TLS, where you don't need wallets. That is coming for our C stack, so for Python 6 Oracle at some stage, but for the moment, we still need to use wallets shown there. The other little minor thing is you showed running ld-config. That's actually not needed anymore with these current versions of the RPMs. You would need it if you're using the zips, but the RPM install does that automatically for you. So it's just a little time saver in the current versions. Anyway, so let's get into the Flask app briefly, which I will have to do very briefly given the amount of time we've got left. So we divided this into two parts. One is just something which loads some data. So you can see at the top, I'm using standard Python 6 Oracle execute, so kind of drop in, creating a table, identity column nicely created, no need to create sequences anymore. And then we're using some data which our Oracle developer relations team has carefully downloaded already. And this is some Formula One data, just pulled out the weather information for particular tracks. It was a little easier to work with. Obviously, using bind variables for inserting data, where this CSV has a bunch of columns, we're just going to pull out 4 columns. And because we're using binds, we want to tell Oracle sizes and things like that, because we're using execute many. If you look down at line 86, so execute many needs to have a nicely allocated set of storage for each column or each data point we're going to insert. And as it scrolls through the data, it might have to reallocate memory unless we do this. And this just lets the memory be allocated up front. So, semi-arbitrary sizes, 20 obviously matches, and 250 match to the table. You could set these to the actual data sizes in the data files if it's smaller. So we're using CSV module from Python, decoding. So this is a sort of magic to work with the URL stream, skipping the header. And then we've got a kind of loop, because we may not be able to call execute many and insert all data at once. In fact, in this sample, the size isn't too big. But in the generic case, if you have lots and lots of data, you may need to batch it up into batches. And that's what this batch size is. So we're just looping through, getting a batch of data into the right format in this data environment variable. And at the end of the batch, we're just inserting that. And at the very end, we might have a few rows left over to insert. And so we do one final insert and obviously commit the data. Execute many has a couple of modes. One of those is quite useful. Not shown here is the batch errors, because you may be working with noisy data, and we have lots more about that in our documentation. That just lets valid data be inserted and then shows you which data is invalid, and you can make the choice about what to do with that bad data. Just ignore it and commit the good data, or try and fix up all those data errors. So Sharad will show running this, but looking at the demo itself. So this is a standard Flask app, and we starting at the top. I guess there's all the comments, importing all of the modules we need. We have in recent versions of CX Oracle, certainly for Mac OS and for Windows, just really made it easy for you to specify which client libraries to use. Sharad's running under Linux, and that's good because that's all pre-configured in the environment variables by ldconfig, as Sharad showed before. I'm going to use a connection pool because this is a web app. Want to use lots of high performance things here. So we're creating a connection pool, certain sizes. Now we've got a fixed pool size here because that's recommended to avoid connection storms on the database. Obviously, just picking up environment variables for the credentials, because the database still needs credentials, even though you're using the wallet. The wallet is just for the certificate. Threaded equals true. Now that's actually always forced on in recent versions of CX Oracle, but if you're using an old version, you need to set that to true for most pools, especially when you've got multi-users. Get mode means that if the pool's busy in use, in this case you've got 4 users already using it, and a 5th user comes and wants a connection, this get mode is going to wait. So their request to get a connection is going to hang and wait until a connection becomes available for them to use. They get a slightly nicer experience in the generic case. Obviously, you can choose the mode, and they could get an error immediately if that's your desire. Session callback actually is a great way to set session state. So connections record session state in the pool and save that across different uses of the connection. They don't. The pool will clear transaction state when a particular user finishes with a connection and releases a connection back to the pool. Now, in this particular example, we're not using date, so it's kind of moot point, but I'm just showing this as best practice, that this would set particular session state on a connection, and this would be called, in this case, 4 times, once per connection in the pool, and this session state would stay in effect for the whole lifetime of that connection. So you no longer need to run alter sessions or other session state things every time you try and get a connection, every particular use in the application. Just hide it away here, and then later when we get the connections in the application, it already has that session state. Now we're dealing with lobs, and it's faster in CX Oracle to deal with those as strings. The only limitation is this limits them to 1 gigabyte in size. So basically it says if the described information for the column is a lob, you get Oracle to return it as a string. So it's faster than the many round trips to access chunks of lobs with the old lob locator method. Flask is very simple. Got an application name, and then we have routes you can set up, or routes, depending which version of English you speak about. And for the main part of the app, we've got 3 routes. Get information for all races, get information for a given race, and just inserting a little bit of weather information for any race that you can choose. Let me look at the middle one first. So getting a given race, so this is the route, it's going to get an ID parameter on the URL, connection from the pool, cursor from the connection, and then I've decided to deal with things in JSON. So I'm using Oracle's SQL JSON functionality, and we're going to get this back as a JSON object. Obviously the keys are the dict, and then the values are going to come back. Where clause, binding, of course, always important. And we're sending it back as a response with application JSON. So we get it nicely formatted in if we're using a JSON tool. Information about all races, very similar, but we're adding this extra JSON array aggregate around it. So we get all of the rows back as one big, nice JSON string. And in this case, because we're getting lots of data back, this is where we need to set that output type handler to say that we're going to fetch the CLOB data as a string without having to do separate calls to access the data from a locator. And then insert, let me go back. Inserting, a little bit of trickery here because I noticed in the data set we were given sometimes there was no weather information. So I thought, well, maybe a person using the post method may also have no weather information. So we're going to insert none, which will be inserted as a null into the database. Obviously we want the say that we're going to get an ID back. Remember, that was that identity value, that the old sequence generation. So we're going to get that back. And we need to tell CX Oracle how much space to allocate. It's going to come back as an integer. And obviously just insert our data into the database, which we're still storing as relational columns. Even though I'm fetching things, returning those relational columns as JSON objects lower down, we're still storing, as you saw with the create statement, as a relational data just for this demo. Obviously, we've got great JSON functionality. Could have done it that way if we'd wanted to. So Sharad, I should throw back to you because we're really running out of time, and I will let you just quickly show that demo before we move on to the little bit of high availability.
Sure. So I'm just quickly sharing my screen. So are you able to see my screen?
Yes, I can see it.
Okay. Okay. So I have made it as big as possible. I hope everybody is able to see it at least. So now that Chris has quickly explained about the application, I'm going to quickly run it. I have already downloaded the app which Chris was talking about. Before running the app, I need to set up the credentials, DB credentials. So for that, I have created a separate shell file, which I'll run it. Now we have set up the DB credentials in the VM. Now let's run the load weather app, because we need to upload all the data from the all the weather information for the race tracks from the URL that Chris mentioned. Okay. Now that the data has been uploaded, I want to show you the demo. So for running this Flask app and creating the web service, you will need to use the following command, the Flask run command. And this Flask web service will run on the port number 8000, and you have to provide the private IP address, which I talked about in my pre-recorded demo for starting this app. One additional thing which I wanted to point out is that you have to open the port number which you're going to in which you're going to run the web service. So there may be restrictions in your company. So based on your company policies, request you to open the port number where you're running the web service. You can use firewall cmd command, and there are various other commands that are available to open the port and monitor the ports. So quickly running it. Yes. Okay. Now the web service is started. So to right now, to access the web service and to get data from the web service or post data into the web service, you can use the any web service request client. You can use Postman. You can use Boomerang. I'm going to use Postman over here. So if you're able to see it, just let me know, Chris.
Yep, it's getting sharper. That's okay.
Okay.
Just readable on a big screen, but I think we'll get the details.
Okay. So as you can see, what I want to, like Chris pointed out, you can get the. I'm just going to run the get command, which will get you all the races weather information, racetracks weather information that you see on the screen. So you have a lot of information, around 118 data sets that you see over here. So if you can also insert data or post data into the database. So to post the data, you have to select the post command, and you have to in the body section, you have to insert the JSON data which you want to post or which you want to insert into the database. So as you can see, I want to insert this data into the database and then run it. Yep. So this data, the latest data has been inserted with ID as 1019. So if you want to check this data, all you have to do is to issue a get command, get request, and the data is pretty much available in right now for you from the web service. So just quickly running the races command, races request. As you can see, all the data is now available for you, and even the latest data has been inserted into the database in the form of a JSON, and you can retrieve it, and you can retrieve the data individually as well. So with that concludes our short demo of creating a web service in Python app using using the Oracle Autonomous Database. Quickly, Chris, I will pass it on to you to talk about high availability.
Thank you, Sharad. Yeah, so let's just finish up with a few slides on high availability and how that impacts ADB and other cloud services. We can take questions at the end if you've got questions. So when that wakes up, as it should, okay, there we go. So traditionally without high availability, you know all of the issues. Common one is, of course, connections just hang when you try and open a connection to the database and network's down. You have to wait for some TCP timeout to come back, and that literally could be hours before that error comes back, and users get a little frustrated. And we don't get any of those high availability features which just happen out of the box. One of the worst things, perhaps, of course, is duplicate transactions where somebody's hit replay, resend, submit a couple of times, and you end up with some nasty things happening to the data and to your financial results and to customers' bank balances and things like that. So we obviously want to use some kind of high availability, and I kind of divide these into a couple of ends. One is the simple, easy way in CX Oracle. So these are things you don't really need DBAs particularly to configure. First thing is to use a session pool or connection pool. We tend to use the terms interchangeably here in the Python world. So when you do the pool acquire, as you saw me earlier in the app and Sharad showed, to get a connection from the pool, that has a socket check to make sure the pipe to the database is still open. And if it's not, then it reestablishes a connection, and pool.acquire will return a valid connection. It's also got another feature called ping interval, where it does a full send across to the database to check that the database side of the connection is valid, that a DBA hasn't done an all system kill session command. And that can be very useful. As default is configured 60 seconds, useful in most cases. You probably don't need to configure that. But certainly without using a pool, without pushing connections back into the pool when you're finished using them, getting them out only as you need them, you lose some of those high availability automatic reconnection capability that you could have available. There's a bunch of configuration options you can put in a SQLnet.ro file. Sharad showed the wallet SQLnet.ro file. You can go and add some of these options into that if you like. Outbound connect timeout. Again, if there's going to be a delay across the network, TCP, you don't have to wait for the TCP timeout. You can actually configure the kind of timeout that you want that error to come back if the pipe can't be created to the database. Receive timeout, send timeout. So if you're actually running a query or doing insert, the database hasn't responded in a particular amount of time, again, you can get an error back fast to the application. Expire time, very useful in a number of situations, particularly if you have a firewall which is killing sessions. We know when we were dealing with some Oracle applications running on the Azure cloud, talking to ADB in the Oracle Database Cloud, that the Azure firewall kicks in after about 4 minutes and kills what it thinks are idle sessions. And of course, the whole idea of a pool is that you have sessions sitting there idle, ready to be used when the app really wants them, and you don't want the firewall to be killing them. So you can set this expire time, which will send a ping across the network to make sure that the firewall thinks the connection's still in use. And you would set it probably to about half the time of the firewall timeout. So if the firewall times out in about 4 minutes, you would set this to about 2-minute ping time. These options, if you don't want to set them in the SQLnet.ro file, you can start using this 19C and obviously 21C Easy Connect Plus syntax. There's a great technical brief on this, and it's in the documentation. You get this URL syntax where you can add those options directly into the connection string the app uses. And the other thing which actually almost gets rid of the receive timeout, send timeout is in the application itself. We have a call timeout attribute. So you have slightly more control because you can change this during runtime of the application. So that again is how long a call across to the database across the network can take. Expire time, by the way, if you are setting that, obviously connect string is very easy, but expire time in SQLnet files only works in 21C. There's some complex thing in 18C. You can add it to the TNS names file. 19C, you can put it in this easy connect string, and a 21C, you can additionally put it into the client side in it.ira. So just check the doc on that, because it's easy to set and not realize it's not having any effect. So those are some sort of basic CX Oracle-ish things that you can do just to make your apps responsive, and so you can handle errors directly. But we also have a bunch of database high availability features, and you know what these are. They all presume that there's a node of the database available to handle work if something goes wrong, if a network to a particular database node disappears, or that node itself goes down. It could be for planned or unplanned outages, and CX Oracle can handle both of these major cases, the planned, unplanned, very well. So there are a bunch of technologies in there. Don't have time to talk about it since we're already out of time, so I'll just run on. We're going to talk about the application continuity, which is the latest and greatest. How does it work? It records the work done by the Oracle Client Library, so it's all internal. Even CX Oracle doesn't know about it. It's been around for a few versions. It's getting better and better. It's enabled by a simple database service setting. So in fact, from the application point of view, it's really trivial to use because it's out of your hands. Somebody else just sets it up and it happens for you. So using the session pool, so the client libraries then know when to start recording. They capture those calls which go across, what gets replayed, data which comes back, so it can later cross-check if it has to redo some work, and some validation data. And if everything goes okay, then of course we just throw it away. But the common case, of course, is that things don't go okay, and then we need to start doing some kind of replay on failure. So we do some kind of validation to make sure that replay was actually enabled. There are some things we can't replay, so maybe we stop capturing. We have to create a new connection to that surviving database instance there in step 2 in the middle. Timeliness, well, we don't want to replay things which are very old, so a couple of time settings there. And if there's a partial work which is being committed, we kind of roll that back as part of the transaction. So then we can replay everything in step 6, all those captured calls, cross-checking as we go. And when everything's good, we return control back to the application. So the application hasn't even been aware that any of this has happened underneath. This is all happening without the user being aware. Obviously, there might be a time delay where we have to do the reconnection and replay, but user satisfaction is much greater because they haven't realized there's something big going on underneath. Some restrictions where it can't be used, a bunch of unsupported calls, objects, AQ, CQN, and we have, in the old days, there used to be a slightly tighter limit on the number of calls we could record. That's been increased very recently in the middle of this year. So there's like a 10,000 internal call limit on fetching and binding and defining, and 250 call limit for prepare calls and all sorts of things. So it's quite high now for the C stack, bringing it closer to the JDBC stack. And then that's just recording, but replay also then fails, particularly looking at the bottom with these things we call mutable functions. What happens if when you first did the transaction, user got a date back, and then of course you now have to replay it, and there's a different date. Do you or don't you want that to be replayed? Does the date matter? Sequence numbers, yes, no, maybe they don't matter. So we have some controls over those things. But for application continuity by itself, replay can fail with that. But then we introduced more recently from 18C transparent application continuity. So this is a variant of it, and the best way to think about this is that you would use application continuity if you had a connection pool, session pool from Oracle, and you would use TAC if you didn't. So TAC actually kind of does better in recognizing when you are and aren't starting transactions and what it needs to record and replay. And you can mark things like those mutables I mentioned, the dates and sequences and things, whether or not you can replay them or not. So in cloud, in ADW, as Sharad showed, there are only 3 services which are enabled, and we don't enable any of the AC or TAC by default. So you can enable your choice of AC or TAC. In the autonomous transaction processing, we have TP and TP urgent, and they do have TAC enabled by default. So you get various levels here. So the level on the auto refer to how much session state we're going to try and restore, how aggressive we're going to try and restore that. And then the 600 is a sort of replay timeout of about 10 minutes. How many seconds after the request was submitted are we going to allow the replay to be valid? Connection string shown is valid for 12.2. There's some good technical briefs and documentation on setting this stuff up. But from 12.2 onwards, obviously Sharad was using 21C. This is a connection string, and you want to set retry and retry delays and things like that, so that you were actually attempting to connect to a surviving database instance. So you're going to go and need to edit the TNS names that you downloaded with the wallet. And then with CX Oracle, just to wrap up, I think this is the second last slide. Obviously, session pool talked about before. Using an order by or group by, I know we're doing some work here to not need that, but if you're selecting data and we're replaying something, we need to check that the results that you got the first time before a failure were the same as when we replay afterwards. So using an order by or group by can stop a failure during replay. And recommend setting these attributes, module and action. Been around for a very long time, so these are very simple things which get piggybacked across the database and then shown in $V views and various reports. And in particular, they get shown in this AC check coverage tool. So this is available with 1911, and the developers say, hey, they've done a lot in 1912, so that's good, and then we're up to 1913 already out there, and Sherrod was showing recent versions. So this is like the AWR for workload repository generation. You kind of enable it, you run your application. You don't need to simulate any errors or anything like that, and then you run the package to get a report. And that report is like your insurance policy. It lets you know what is and what isn't covered. I mentioned some things weren't covered. And gives you things like the amount of time that each block ran, and then the amount of coverage you had for that block. So you may know that you're kind of 90% covered, so that 90% of the time if there's a failure in it, then you're going to be covered, 10% not, and you can work out how to rejig your code and how it works, or upgrade Oracle to get new features which have better support as you go on. So that's it in a nutshell. And we have gone a few minutes over time, so apologies for that. But I hope you found that session useful. You can contact Sherrod and myself, shown on screen, email, Twitter, and we are running a very popular blog out there, and obviously final link to Python 6 Oracle. So please do get in contact with us. Need your input. Let us know what's working for you, what isn't working, and you can help guide where the driver development goes, and make sure that we can go back to our managers and say, hey, we had these 5 customers say they were really having a good time with it, or 3 are not having a good time and they want these new features from the SQL language because that's where the problem is, or from the driver. So start a dialogue with us, make it two-way, and we can all make some great technology and use Oracle Cloud effectively. Thank you very much. Thank you, Sherrod. Thank you, Francisco. And it's back to you.
Thank you. Thank you, Francisco.
All right. Thank you so much, Sherrod. Thanks so much, Christopher. Excellent and very informative session as always with you guys. If anyone is watching the replay, or you're watching through the Facebook, and you want to make questions to Sherrod and Christopher, please feel free to contact them directly to the emails on the screen, or to their Twitter handlers also on the screen. I'm getting no questions from this streaming at the moment. Just giving a couple more seconds just to see if anything come through. If it's not, please, thank you so much, Christopher and Sherrod, for taking the time to present. My dogs just went nuts over here. And please take care and be safe, and hope to see you guys face to face when all the events start to go back to reality of face to face.
Thank you, Francisco.
Thank you.
Goodbye, everyone.
Thank you.
Bye, everyone. Have a wonderful day, evening, or afternoon, depending where you are. Bye-bye.
CloudDB, shaping your new normal.